What will be the equivalent resistance between the 2 points A and D? A 30 ohm, B 40 ohm, C 10 ohm and D 10 ohm. To approach this question, first of all, we have to disregard B and C single arm resistances because we have to find the resistance between A and D only. So, and here our subscripts given are R1, R2, R3, R4, R5 and R6. Since B and C arm is disregarded, that is resistance over there is disregarded, we can take R2 and R3 as one series combination resistors and R6 and R5 as series combination resistors. So we can find the total effective resistance by first of all finding the series resistance of R2, R3, series resistance of R5, R6 and the parallel resistance of R2, R3 and R5, R6 as a whole, and then adding this parallel resistance to A R1 resistance and D R4 resistance. That's how we get the equivalent effective resistance. First of all, let us find the resistance of R2 and R3. R series 1 is equal to R2 is 10 ohm and R3 is also 10 ohm. So we have there is 10 ohm plus 10 ohm 20 ohm. Then we have R series 2 which is R5 and R6. That's how we find is 10 ohm plus 10 ohm which is also 20 ohm. Now we have to find the parallel resistance of this section. So we have Rp is equal to R2 R1 by R1 plus R2. Here R1 is 20 ohm. That is first series. Then we have second series 20 ohm. Then we have 20 ohm plus 20 ohm which is 400 by 40 which is 10 ohm. Now we have found the parallel resistance. Now all that's left to add is R1 and R4. And now we can understand the pattern, and we can from the figure we can understand that the parallel resistance is in series with R1 and R4. So to get the effective resistance, we just have to take the series resistance of R1 plus R parallel plus R4. That is 10 ohm plus 10 ohm plus 10 ohm is equal to 30 ohm, which is our option A.